As a competent professional working for ABB, no one understands better than you what the risks are when working on low-voltage electrical installations. You know what you have to do to keep yourself and others safe and to protect the customer's equipment from damage. But to put things into perspective, since 2014, 81% of all electrical incidents within ABB have occurred whilst working on low-voltage installations. However, our customers often don't fully comprehend that work on their low-voltage equipment can be equally as dangerous as that undertaken on high-voltage plant and apparatus. This is a common misconception, and consequently, they may ask you not to de-energize the equipment because they're not concerned about lost productivity. The customer has a valid concern. De-energizing electrical control or protection equipment may mean significant production losses. It could take hours or even days to bring their process back up to full production. But there is no amount of production that's worth risking a serious injury or death. So what do you do when faced with a customer who insists that you shortcut or ignore good electrical safety practices? Respectfully refuse. You need to respectfully help the customer understand why it's in their best interests to follow good safety practices. Explain that, based on your experience, you believe the best thing to do is de-energize the equipment before working on it. Acknowledge that you understand the production loss and regret that it's necessary, but help the customer understand the risks we face if they don't de-energize their equipment. Ask them what the cost to their company would be if there was a short circuit or arc flash that killed someone in their facility. Ask how much production they would lose if their electrical control equipment was seriously damaged and had to be replaced. Your goal is to help the customer see that following your advice is in their best interests. Of course, you won't always be able to convince them. When that happens, apologize to the customer and explain that you do not feel safe or comfortable doing the job. If possible, you may want to put them in contact with your supervisor or foreman. The bottom line is that you should never do work that you feel is dangerous to you, others in the area, or the customer's equipment. Your manager will always back you up if you ever believe you're at risk. The 7 steps that save lives. Remember, safety and integrity are our top value pair and form the basis of our license to operate. When you are comfortable that you can safely undertake the job, there are things you must do to ensure the highest possible level of safety. These are the 7 steps that save lives. Step 1. Prepare for the work. Perform an on-site risk assessment or a job hazard analysis and be in possession of a clear work order to execute the work. Where required, an access or work permit is to be obtained by the person in charge of work or PICW. Ensure the fitness and technical competence of workers. Check that they have the correct tools for the job and engage the person responsible for electrical equipment or system to review single-line diagrams, schematics, and switching plans. Determine and select the correct ARC-rated personal protective equipment (PPE) and associated PPE as defined in the Arc Flash Risk Assessment or ABB matrix. Determine approach distances for shock based on nominal voltage and arc flash for steps 2 and 6. Decide on appropriate work methods and finally, initiate the permit to work process. Remember, a permit to work is not always issued for low voltage work. In the absence of any other control document, an ABB electrical permit to work or a limitation of access document shall be utilized and use it in the same manner as you would for high voltage work. By adopting this same process, there is less chance of anything being missed or overlooked, and a consistent approach can be applied to electrical work at any voltage. Step 2. Clearly identify the work location and equipment. Use your senses, touch, smell, sight, to identify any problem areas. Define the work area using barriers or barricading and label the equipment by placing warning notices on any adjacent panels you're not working on. Always exercise extreme caution when working on rear access panels and avoid distractions such as talking or texting on the phone. Step 3A. Disconnect all sources of supply. Wherever possible, any switching should be undertaken remotely and should only be performed whilst wearing the correct PPE identified in Step 1, and also consider the dangers of backfeeds from outgoing circuits onto parts being worked upon. Step 3B. Secure against reconnection. Implement lockout, tagout, and avoid allowing other work to take place at the points of isolation. Be sure to fit your own locks on the energy isolation devices using a multi-hasp if required, after first ensuring that the customer is in agreement. Step 4. Verify the absence of operating voltage. Utilize only approved, correctly rated and inspected detection devices and wear the appropriate PPE identified in Step 1. Remember to always test the neutral conductor to ensure it is free from operating voltage, as in low voltage systems it is common to see current and voltage flowing due to unbalanced loads and harmonics. It is extremely important that you test the voltage detection device on a known voltage source, such as proving unit, or by using the detector's test button if designed into the device, then test for the absence of voltage. Finally, test the voltage detection device once again to ensure it is still working properly. This three-step method, often referred to as live, dead, live, is required without exception. Also remember, when carrying out the work, if you have any doubts, always test before you touch. Step 5. Carrying out earthing and short-circuiting when required and according to the risk assessment. For low-voltage installations, earthing is not always required. The need for personal earths must be considered during the job planning process in Step 1. Where required, use insulated tools to apply portable equipment for earthing and short-circuiting whilst wearing the correct PPE identified in Step 1. Always ensure that you connect any earth lead to a suitable earthing point first before applying to any conductors. By applying your own local or personal earths, you shall ensure that the equipment is free of any residual charge, induced voltages, and protected from any potential short-circuit fault current. It is highly important that you identify how many sets of earths have been applied on the control document to ensure they're all removed before energizing the circuit. Step 6. Protect against adjacent live parts and take special precautions when close to bare conductors. Consider the minimum approach distances determined in Step 1 and apply screening. Take special precautions such as wearing the correctly rated insulated gloves and leather overs and using insulated tools to prevent inadvertent contact potential. This is especially important when marking live components or cables or while placing protective barriers or screens around the area as you prepare to do the job. In especially dangerous situations, like working in close proximity to known live connections or where there's low lighting, difficult access or higher voltages, take extra precautions. Always remember to avoid blind reaching into panels or switchgear. If you cannot see the point of contact, stop work and reassess how you are to approach the task. Also remember that extra diligence is required and additional controls put in place before undertaking any live testing or off-load diagnostics. Any such activities must be thoroughly risk assessed and any additional protocols agreed at the job planning stage. Now that you've created a safe work area, you need to take the final step before beginning work, which is Step 7. Complete the permit to work and walk the permit. Where applicable, the person who has undertaken the isolations and earthing will walk the permit with the ABB PICW and will sign it to confirm agreement to the safety precautions in place and work to be undertaken. If you are the designated ABB PICW and utilising the ABB electrical permit to work, you will also prepare and sign on to the permit, confirming that you understand the isolations and safety controls that are in place and agree that it is safe to begin work. The person in charge of work then gathers the working party and together they walk down the permit to confirm isolation points, verify all circuits are isolated and secured, ensure all parties are integrated with the lockout-tagout arrangements and check that any earths are correctly applied. The PICW then answers specific questions from the working party, ensures the work can proceed without danger, and validates the permit to work. The permit formally documents the steps taken to create a safe system of work, including many critical facts about the work to be undertaken. Understanding and agreeing to these facts is essential to safe completion of the work. Once you sign, you are responsible for ensuring the safety of yourself and anyone else in the immediate work area. You can't change what's been described in the permit without the agreement and signature of the client responsible person. Be aware of induced voltages from nearby equipment. And of course, you should wear all of the appropriate PPE for the job. Make sure anyone working in the area, especially people who don't understand the dangers of electricity, like crane drivers and civil contractors, know where the live parts are located. Are there any issues with the live equipment? If this equipment fails, could it affect your safety or the safety of others? Could you directly affect live parts, particularly when handling cables or conductors or using large plant equipment? Could you indirectly affect live parts, for example, interfere with earth conductors, protection and control supplies, or heating and cooling? Continue to reassess the risks, asking yourself these questions. Remember, should the PICW or permit holder need to leave site for whatever reason, all work must stop unless the permit is transferred to a new PICW or permit holder. Should this happen, the work area and apparatus being worked upon shall be made safe, and all tools, equipment and personnel must be removed from the work area. Similarly, if you leave the work area for an extended break, lunch or any other reason other than a washroom break, you must notify the PICW and sign off on the permit to work or other document that is posted to control the safe working zone. When you return, you must again notify the PICW and sign back onto the permit. Often things can change when working parties are not present. That is why it is so important that after lunch or extended breaks away, the work area is checked and the permit walked again before work recommences. As an experienced professional, you are responsible for assessing each job and confirming that it can be done safely. If you aren't comfortable with doing the job, you should discuss this with the client responsible person. If you aren't able to resolve your safety concerns, respectfully decline to do the job and help the customer understand why. When you are confident that you can safely do the job, follow the 7 steps that can save lives to ensure that the job will be completed safely. In every job, every day, safety always comes first. We want everyone to go home healthy and injury-free when the job is done. Here are the 7 steps once again. Step 1. Prepare for the work. Step 2. Clearly identify the work location and equipment. Step 3A. Disconnect all sources of supply. Step 3B. Secure against reconnection by applying lockout-tagout. Step 4. Verify the absence of operating voltage. Step 5. Apply earthing and short-circuiting. Step 6. Protect against adjacent live parts and take special precautions when close to bare conductors. Step 7. Complete the permit to work and walk the permit.